Convolutional neural network has shown amazing success in computer vision tasks. CNN outperforms every conventional schemes which was widely used in computer vision communities. From 2012, after AlexNet winning the ImageNet challenge, I think all of computer vision research communities turned their attention to deep learning, and all of them now working on how to utilize, how to manipulate, how to leverage the property of CNN, and how to combine with other techniques to improve their performance, to speed up their computation, to save the memory space for edge device and many other applications. So maybe you already know the success history of CNN. So from this point, I'll explain why CNN outperforms all the existing computer vision algorithms, and also why we have to use convolutional neural net structure rather than fully connected neural net structure for image task. Okay, so in the fully connected neural net structure, we usually have neurons for each layer, and we connect the neurons between the layers by edge, and each edge having one parameters, and each neuron also has one bias parameters. So that is typical fully connected neural net structure. And also in the neural network, the width, and depth, both are very important. We have to have some sufficiently large width to deal with very complicated signal, and we have to have some depth to generate some very complicated nonlinear classifiers using the neural network. So both depth and width are very important, especially for very difficult classification tasks. And image classification and object detection also very complicated classification task for us. But although CNN nowadays make the image classification like very easy task though, but you know, before 2012, before AlexNet, it was believed that image classification is very difficult, and it is very difficult to compete with human, because at that time the error rate was much higher than humans error rate. But now computer vision task, CNN do much better than human. Okay, so why the fully connected neural net works not good with image task is, for the complicated task, for the difficult task, we have to have high enough width and high enough depth. But when you increase the width and depth, the number of parameters also increase very rapidly. That is the problem. When you increase the number of parameters, first, there is overfitting issue. Second, it is very hard to train. Hard to train. What does that mean? Essentially, in the learning process, we want to minimize some learning loss function. When you have better parameter set, you can control the parameters better. And the main goal of training process is there is some objective function, loss function L, and we can control the parameter beta. And by controlling the parameter, we want to minimize the loss function among all possible the parameter range. But essentially, when you have very high very huge number of parameters and your architecture is very complicated, it is almost impossible to solve this optimization problem. You cannot find beta that really minimize the loss function, but you find some beta head such that L beta head, the loss function at beta head is much bigger than minimum loss function. In that case, even if you have very high capacity, very huge number of parameters, your real performance is not good, even for the training data point, because your parameter is far from the optimality. Okay, so because of these two issues, there is some overfitting issue. So your test error will be much higher than your training error. That was the first issue. And because of this training issue, your training error itself also very high. That was difficulty for using the fully connected neural network. And to improve the performance, we want to decrease, we want to reduce the number of parameters a lot more than before, while keeping the widths and depths, because widths and depths are also very important to build a nice classification algorithm. So CNN actually achieved this. CNN used much less number of parameters while keeping the same widths and depths. And CNN used local information to reduce the number of parameters. Essentially, for the image classification or object detection task, it is extremely important to understand the local behavior in your image. Where is edge? Where is this round shape of edge? Where is this horizontal edge? Where is this vertical edge? We first understand the boundary of objective, and we want to understand the shape of the edges. That is the first step of your understanding of input image. We have to understand where is window, where is the wheel, where is the edges of your car image to discriminate car and other images. Okay, so it is very, very, very important to understand the local behavior, and also it is less important to understand the relation between this pixel and this pixel. When the distance between two pixels are very long, the correlation between two pixels are less likely to decide the objective, the car or cat or something. So from this property, the CNN designed a filter and convolutional operation with filter. Okay, so essentially, the CNN looks like this. There is some input map, and there is some output map for each convolutional layer. So this is input map, and this is output map. Sorry. So input map like image. There is width or height and width, and some channels. Like RGB in the color picture. At each time, to understand the local behavior, we can define a filter. The filter will place local area of your input map or input image and take the element-wise product sum, the inner product. You just simply do the inner product between filter and your local map or local image. The result, the input, the inner product between filter and local image will be recorded to the output map. And the position of output map essentially indicate the location of your filters. Okay, where your filter located at your input image to calculate the value of your output map. And you reuse the same filter again for each position of your output filter. So you just shift your filter one by one to record the local behavior of your input image. So at each pixel of your output map, you take the inner product between filter and the input values. Then this output map basically record the local behavior with respect to one specific filter for each position. And to understand the different patterns like a horizontal edge or vertical edge or some round shape, you can define several different filters and each filter will generate a new output map. That's it. That's the convolutional neural net behavior. And why this is great? We can understand the local behavior very well. And also, so here the number of neurons for this area is W product H product number of channel in. The output neuron, number of neurons also W out times H out times C out. With fully connected neural network, if you want to make the same size of neural network, same width of neural network, you have to define a fully connected weight matrix. And the number of parameters to define such fully connected weight matrix is, for FC, the number of parameters will be W out times H out times C out times W in times H in times C in. The number of parameters to define the fully connected neural net. This is very, very huge. But with CNN, convolutional neural net structure, the number of parameters you need to have for this structure is the filter size. Let's say this is K times C in. This is the filter size times C out, because you make the C out different channels, C out different output maps. That's it. So there is common value C in, C out. Here is C in, C out. But here K by K, but here W in, H in, W out, H out. Usually K by K is much smaller than W in and H in, W out and H out as well. So because convolutional neural network reuse the same parameter again and again, while it can extract the local information very well. So from this, you can save the number of parameters a lot more than before. Basically, convolutional neural network used our knowledge on the image property. Image usually have some local information structure. So where to understand the input image, it is very important to understand the local behavior. So we can save the number of parameters by leveraging the local behavior. This is the main concept of convolutional neural network, and using this concept we can write a very huge success story.